the different methods of operation. Let us look into the methods of carrying out the survey in the field during my next lecture. So, in today's lecture, we have understood the differences between the three principal methods of electrode arrangement, which means advantages and disadvantages of Venner, Schlumberger and dipole-dipole method. After that, we had a look into what are all the things, especially what is the relation between the distance between the electrodes and depth of penetration, and also toward the end we had seen what is the area we are investigating beneath the surface. Thank you. Hello everyone. In the previous lecture, we had seen the advantages and disadvantages of different electrode configurations that are used in electrical resistivity methods. Then we had also looked into what is the depth of investigation and area of investigation. Today, we will see how electrical resistivity survey is carried out in the field. There are three principal methods of carrying out the investigation at the field. One is electrical profiling. Number two is vertical electrical sounding. Number three is 3D resistivity sounding. These are the popular methods of carrying out the survey in the field. What are they? We will see one by one. How do you go for, when you should go for, how will you carry out profiling? That is what we are going to see. It all depends on what is the answer which you want. What for you are carrying out the investigation? Are you carrying out the survey for understanding what is the mineral resources beneath the surface? You may be a exploration geologist, or you may be a mining engineer wants to quantify the resource beneath the surface, which means you are targeting a larger area. Which method of field investigation we will go in for? We will go in for this. Suppose if you are a hydrogeologist or a water resources engineer or a groundwater engineer, you may be interested in locating a place for drilling a water well, for drilling a high yielding water well. In that case, we will go for vertical electrical sound. Or you may be a geotechnical engineer interested in knowing how the subsurface geology changes along a profile. You may be interested in estimating the cost for a elevated roadway or elevated railway line. You are going to drill, you are going to erect piles every 50 meters or every 75 meters along a straight line. In that case, you need to carry out electrical profiling. I had given you an overview of all these three methods. Anyhow, let us see in detail in the following slides. First, let us take up electrical profiling. So, what is electrical profiling? In electrical profiling, our aim is to understand what is the variation in the type of rocks, what is the characteristics of the rocks below the surface along a particular profile. So, the x-axis here is the distance and y-axis is the apparent resistivity. How can we achieve this? We will be able to carry out this investigation by moving the array, means electrodes, right? Moving all the 4 electrodes along a profile without changing the electrode geometry, which means electrode configuration. Distance between the electrodes are kept the same, but we keep moving along a profile, right? For example, let us take the same simple case of Venner method, or 4 electrodes at same distance 1 meter. What is our station number? This is our station 1, that is the center point. Now, let us shift all the 4 electrodes like this. This is station 2, right? These 4 electrodes are now used. Now this is going to be the next station. This is station 3. So this is how we keep moving the electrodes along a profile to carry out electrical profiling, or this is also popularly called as lateral exploration. Okay, which means center point is keep moving. That is what I have written here, 1, 2, 3, they are all nothing but the center points of our electrode spread. These are the stations of our investigation, right? This is possible both by Venner as well as Schlumberger or dipole-dipole. We can use any electrode configuration, right? Please remember the method of carrying out the investigation in the field, right? All these 3 methods can be carried out by any electrode arrangement. That means electrical profiling can be carried out by Venner, Schlumberger or any other method, right? The same is applicable to vertical electrical sounding. We can do it by Venner, Schlumberger or by any other electrode arrangement. The third one, 3D, also can be carried out by any electrode arrangement. So, there should not be any confusion, right? We had initially seen about the way of arrangement of electrodes. Now we are looking into how the survey can be carried out in the field. So, as I was telling you, the survey can be carried out both in Schlumberger and Venner method. So, here in the diagram I have drawn, I have showed you Venner arrangement. Suppose if you are going to follow Schlumberger, what you will do? This is the profile, A, B, M and N are here. Okay. So, the center point of our station is between these two. We have completed one survey. Now, we are shifting to a newer location. These two are our potential electrode, these two are our current electrodes. Okay. This is the center of the spread. So, this is station 1, station 2, right. So, what is the electrode configuration we are using? We are using Schlumberger, but carrying out electrical profiling. In this method, what we are doing is, we keep the distances between the electrodes constant. The center point of the spread is changing, right? That means we are keep moving, progressing along a profile. Our center point alone keeps changing, but the distances between the electrodes are remaining the same. That is what is known as electrical profiling. Sometimes situation may warrant that it may not be sufficient enough for us to have the same electrode spacing. Let us look at this diagram. Now, we have used Venner method in the first diagram I have drawn. Please focus your attention to this. Let us imagine the distances I have drawn is only A is equal to 1 meter. Right? Imagine A is equal to 1 meter. A is the distance between the electrodes. If it is Venner method, what is the depth of investigation? We have seen already, depth of investigation in Venner method is equivalent to approximately equivalent to A, which means when you do profiling as I have drawn here with a electrode spacing of 1 meter, what is the depth of our investigation? Depth of our investigation is only 1 meter all along the our profile, which means we have understood the lithological variation just 1 meter below the surface of the earth. So, in some situation 1 meter of investigation may not be sufficient. For example, you are interested in laying a road. For a construction of a road, if the terrain is having a nice terrain, that means there are not much of a clay, then 1 meter of investigation may be sufficient. On the other hand, you are interested in understanding the lithology for burying a pipeline, maybe to transport water or transport even oil or some other fluid beneath the surface, right, or gas, right, a large pipe which is going to be laid, let us say at a depth of 3 meters. So, you want to understand the construction, the pipeline will be buried by cut and cover method. So, you need to understand what will be the cost of carrying out the operation, right, carrying out the earth excavation, right, and burial of pipes, what will be the cost, whether any support is necessary for the excavated area, whether any reinforcement have to be done, any barrier walls or barrier sheets have to be provided. So, in that case, you need to investigate up to, you have already decided the pipeline have to be 5 meter below the ground level. So, our depth of investigation need to go up to 5 meters. In such a situation, we may need to do profiling for 2 or 3 distances, right. As you can say here, as you can see here, A can be 10, 15, 20. In the example which we were discussing, we want to bury the pipe at 5 meters. So, we may be interested to know the lithological variation up to 5 or 6 meters, right, because you can't restrict only to 5 meters, little bit more. So, you may need to do, A can be at 2 meters, 4 meters, 6 meters can be the distance, right. So, it all depends on what is the question you need to answer. Okay. As I said you previously, it is you are going to construct a maybe a rural road road. In that case, there is no need to go beyond 1 meters. Suppose you are interested in constructing a national highway, right? For that, the requirement will be much more stringent. A heavily loaded tankers, multi-axis vehicle need to pass through. In that case, depth of investigation have to be much more, maybe 6, 7 meters or up to 10 meters if the region has got clay, right. So, it is better to carry out profiling for 2 or 3 distances, right. How do we do that? That means first let us do a profile for 1 meter, then repeat the profile for with 2 meters, with 4 meter A spacing and so on. Okay. So, this is how survey will be carried out in electrical profiling. Though we said we can use any electrode configuration, which arrangement is better to carry out profiling? Is it Venner or Schlumberger? Which arrangement is better? It is actually better to use Venner arrangement for profiling, isn't it? Why? Because there won't be any confusion when you carry out the survey in the field, because it is very clear to us we are doing Venner method. According to Venner method, distances between the electrodes are the same. Okay. So, here we have drawn a diagram showing profiling carried out with a electrode spacing of 1 meter. So, very clear, right. We can tell our colleagues or other people who are helping us in the field, yeah, please arrange the electrodes at a distance of 1 meter. It is easy. Not only that, when you do the survey, it is also convenient, right. Please look at what I am drawing. These are the 4 electrodes. Now, we decided to keep the electrodes at a distance of 1 meter. So, our first station of investigation is this, that is the center point. We have completed one measurement, right. Now, what we can do is, this is going to be our second station of investigation. This is going to be our second station of investigation. For investigating station 2, we need to remove this electrode, plant it here, reconnect the cables. So, this was previously current electrode. Now, the previously potential electrode, this is potential electrode previously, now it has become a current electrode. This is current, these two are potential. Okay. We have completed the survey. Now, this is going to be our station 3. Now, this becomes potential, this becomes current, this also becomes current. Okay, current. Okay. So, this is how we can carry out the survey with little more faster, because there is no confusion. Am I clear, right? So, these are the electrodes, right. Now, I use these 4, next time I use these 4 electrodes, next time I use these 4 electrodes. So, this is how I progress along a profile using Venner method. So, it is preferable to carry out profiling by Venner arrangement, right. So, what is the purpose of carrying out profiling? Our aim is to understand the changes in the lithology or changes in the subsurface along horizontal direction, along a horizontal direction. So, we can carry out survey preferably in Venner method to conduct investigation to know lateral variation in the geological formation, right. And to choose the appropriate distances between the electrodes, sometimes we also do a preliminary investigation, right, at a small stage, so that we can understand what can be our spacing, electrode spacing. If we are going to follow Venner method, can we do profiling with a distance of 2 meters, 4 meters? For that, we can also do a test survey preferably, right. So, when you conduct electrical profiling, what are all the information which we get? So, what we are going to do is, we are going to plot the resistivity versus distance diagram, apparent resistivity versus distance, right. That means you would have chosen station number 1. So, I will go to the previous page. Let us say this is station 1. From station 1, 2, 3, we are progressing along a line. Okay. So, that is what is distance. So, here too you can see a profile, distance versus rho A value. So, I just plot different station resistivity values as you see here in this graph. Okay. So, we have a profile showing as the distance versus apparent resistivity. That is what we are getting, right. Then after plotting this, any major change in the change in the apparent resistivity indicate possibly the anomaly or the contact between the different lithological formation. So, sometimes if it is very symmetrical, as I have written here, probably indicating a anomaly. So, here you can see, right, distance versus apparent resistivity. So, this is distance and this is apparent resistivity. Here you can see there is a symmetrical anomaly, right. It is almost like a inverted bell shaped curve, indicating there is something anomalous present below this region, right. When we investigated, it is nothing but a intrusive rock. That means this is the ground surface. Here you have a intrusive rock. On the other side, you have another type of rock. So, the intrusive rocks are generally much more compact, more solid, having comparatively higher density, and hence there is some resistivity contrast. These rocks are much more resistant to flow of current, due to which we are measuring high resistivity, right. So, electrical profiling helps us to understand the contact between different layers in a vertical contact. In other words, along a profile, how the lithology changes. Here, just reverse. Here we are getting a negative anomaly. That means resistivity is very less at a central place. Possibly it is a faulted or fractured region which is having more water compared to the sides. So, this is how interpretation is done, carried out in electrical profiling. That means we basically try to understand how the resistivity varied along a particular line. So, this is how the interpretation is done. So, generally electrical profiling are carried out whenever we need to carry out some projects along a particular line, maybe a bridge or sometimes a dam, or especially roadways, railway lines, or pipeline infrastructure. Even for transporting oil, it is mandatory that we need to carry out survey to understand the subsurface geology. Suppose pipelines or even electrical cables are going to several hundred kilometers. To understand a long profile before carrying out the actual work, we try to understand the subsurface by electrical profiling method. Right. Here are some examples, right? Different authors. For example, these two authors have done a interesting work a long time ago to understand how the horizontal variation in electrical resistivity can bring out the presence of a fault. What is a fault? This is the ground surface. There is a major discontinuity along which rocks have moved past each other in the geological past. This is what we call it as a fault line along which blocks of rocks have moved over the other. So, over such a terrain, electrical resistivity was carried out. Electrical resistivity profiling was carried out by moving the electrode along a profile. What we see here is from the fault line, this is the fault line, on either side they have plotted the apparent resistivity value versus distance. You can see just over the center point, over this point, you have a sharp rise in the resistivity value from compared to left side to the right side. What is the reason? Possibly during the process of faulting, the much more resistive rocks have moved upwards. This is a more resistive rock, whereas correspondingly on this side the contact, this is the contact which would have been somewhere here, the same resistive rock, high resistivity, this is also high resistivity rock, high or true resistivity I am writing, right. This rock has moved upwards, whereas the same rock on the other side has moved downwards. So, here you have a formation which is having comparatively low resistivity, right, due to which on the left hand side the apparent resistivity is less, but here the resistivity is sharply increasing when we move our electrodes toward the right hand side of this profile. So, electrical profiling is able to bring out a buried major geological structure here. Same study, similar studies or a similar study carried out by these researchers have helped us to understand the horizontal variation in the lithology, right. Here you can see they have used Venner method. In the first case, the theoretical computations were made. In B, diagram B, we have a observed field curve and as well as the interpreted geological cross section. The third one is a plot of theoretical plot of hemispherical sink present at the center, right. Let us take up the first case. In the first case, there is a rock everywhere, right, and at the center there is a kind of hemispherical sink like formation is present, which is having certain resistivity, right. The resistivity of this small sink is comparatively lesser than the surrounding rocks, right. Compared to this rock, the sink at the center is having lesser resistivity, which is very clearly picked out when we conduct the resistivity profiling. So, this is the profile we have investigated. Here you can see this is the variation in the apparent resistivity. Apparent resistivity was hovering here, just above this sink the resistivity has dropped down. So, we are able to clearly bring out the reduction in the resistivity indicating the presence of low resistivity zone at the center. Similarly, here on B, we have carried out a similar study where the thickness of the shale is much more, right. Further, the same low resistivity formation also extends to the either side. That can also be brought out by the resistivity profiling. What is very evident is this low resistivity measurement here indicating just beneath that you have the low resistivity zone. Similarly here too. So, for different configurations they have tried to understand what is the impact of the change in lithology on the electrical profile. So, this study also indicates the applications of electrical profiling in understanding the difference in lithology along a profile. So, during this lecture today, we have seen what are the different methods of carrying out the field work by electrical resistivity method. We had seen there are three principal methods. One is electrical profiling, then the next is electrical sounding, third is 3D sounding. So, we will continue some more examples of electrical profiling in the next lecture.